Phone fell. Let's just figure this out. Let's figure this out. Okay. So basically this stream, I'm actually gonna log in on the coding channel right here and just shut the volume off. So now we're gonna kind of get into it as much as we can. So yeah. So basically you know, we learned a lot of things, right? In the past tutorials, we learned about variables. We learned about, you know, kind of like the definition of a computer. You know, that there needs to be an input. You know, then there's an output. You know, we learned about, you know, kind of like what is a programming language. And what we're going to be doing is the first way to kind of know how a programming language, if it works or not, is if you can run the Hello World you can run the Hello World program. So the Hello World program, and I'm going to get this set up right here, is basically making your program say Hello World. So right now you don't have to understand this at all. We're going to kind of circle back and deconstruct this a little bit. Okay. Something I just realized is I forgot to record. So I'm gonna pretend that I wasn't just giving an introduction about what I'm gonna be explaining, because I actually need to be recording this stuff. Hello. So we've been talking a lot of stuff, kind of conceptually about programming. You know, we've been talking about we kind of started on the definition of a computer that needs an input. You know, it processes the information and then it has an output. And you know, we kind of try to make like almost like a calculator program. If you can go back in Unit 0, in the Unit 0 playlist, they'll kind of go into everything. So for today, we're going to kind of start with, we're actually going to start programming. So what you see here is basically this is how you start programming. We're using IntelliJ IDEA, which is an IDE. So basically what an IDE is pretty much what, you know, a word processor is to a Word document. This is basically where you write the programs. So we're using Java as a programming language, and you know, we're gonna kind of circle back to everything, but basically the first program you ever kind of want to write when you're first starting any kind of programming language is the Hello World program. So we're just gonna get started here. So you don't need to understand what, you know, I'm about to do, what's about to go on. But all we're gonna accomplish is making this program say Hello World. Hello World. So you want to save it. And you want to run it. And once we run it, basically what it should do is it should say Hello World. Oh, I think it's still loading. It's still loading. Okay, it loaded. So it says right here, this is basically the output of the program. It says hello world. So that's kind of how you make a hello world program. So if we were going to create another one, if you got IntelliJ IDEA started, it's basically to kind of utilize this tutorial in the best way possible. You're probably wondering like how you got to this point. So basically what you wanna do is go back to the other tutorial where I'll explain two things. One, how to download and install IntelliJ IDEA, and how to download and install the JDK. So those two things, the JDK makes it so that your computer can run Java code, and I believe there is a, if you type in, I'll actually try to include this in a window. There's a way you can know if your system is able to run Java code, and I'm going to include the command prompts in this. Let's just check this out. As manager. Hold on, that's the wrong window. No. Yeah, some reason command prompt can't work. I don't know why though. Yeah, it just doesn't capture the window, but what you can do is you can type in I'll just read it out. You can type in Java space dash version, and then it'll basically either either freak out and say we don't know what's going on, or it'll say the Java version and everything, so it'll basically say that it recognizes that Java runs on this computer. So that's a way to know that Java runs, but the only way that Java really will run is you gotta download and install the JDK. So usually there's many installers that'll kind of do that for you pretty much, where you just have, it's like downloading and installing anything. And then download and install the IDE. So the IDE is basically a program to write programs. That's kind of like what generally an IDE is. And the IDE we're using is IntelliJ IDEA. So as you can see, like we know that if the Hello World program works, then any program works. So basically, that's like the way to know that. That's like the way to know that. That's kind of like the most basic program you can write. So it's kind of like the base case, where that if this works, then now you know that all the other programs will work. So moving on, we're going to kind of reinforce other stuff. So we're going to talk about Java. Just got to change the color here. You know, we kind of talked about this notion of high-level programming languages and low-level programming languages. Like, what does that mean? So, basically, the more it's a, oh, I don't want another line. The more it's a higher level programming language, right? The more it's a higher level programming language, the more it is understandable to a human, a person. You know? And that's going to be like the kind of programming language we're using right now. Like this would be Java. Maybe I can even type Java in here as an example. But there's many other examples. There's Java, you know. There's also other ones. There's, you know, any kind of C programming language. You know, things like that. But if you remember from the other tutorials, basically the lowest you can get, kind of the hardware of, you know, like the computer, like what the computer understands, is computers understand zeros and ones. So basically you're going from the zeros and one, as much as a programming language, because a programming language is like how you're creating a program, is the more closest it gets to what a computer understands, like the zeros and ones, the more it's a lower level language, and the more you're getting it to where it's kind of like in English, where like, you know, you can make like a program, like if you kind of look at the program, you know, I'm gonna try to get this up here. Like if you look at it, it's basically in English. Like maybe we don't exactly know what it means, but system, out, print line, we're not seeing a bunch of ones and zeros. We're getting really in terms of what humans understand. So that's basically what, you know, we mean when we're talking about higher level languages and lower level languages. And in general, let's just kind of learn more about oh, by the way, that is actually okay. So I'm now able to, I think, show you command prompt. Okay, so I don't know. For some reason there was some issue with command prompt. It wasn't able to work. But this is what I mean. So this is how you find out if Java works on your system. So you type in, you know, Java lowercase version, and you know, you give it time. You just give it time, and it'll basically tell you all about the Java running on that system. So basically, let's say you download the JDK, and you know, this first time you're downloading and installing JDK, and you're not sure if it works. And again, you know, yeah, you know, like, and you're trying to find out if like does Java work. All you have to do is go to command prompt and type in Java -version, and then you'll know if Java is able to run on your computer, where that if you're just able to write any kind of Java code in general, it'll work. So that's basically it. So yeah, I just wanted to show you that. Another thing I'm going to kind of show is a walkthrough of just Java in general as a programming language. So we're going to learn by none other than Wikipedia, right? But but I just thought it might be just kind of a good idea to just like, because it does give like a broad definition of it. But Java is a high level language, class based and object oriented. So basically, what that means is, like, in general, I'll put it this way: it's kind of like, I don't actually know any other language other than English, but if they do say that if you learn like Latin, that because of what you learn when you learn Latin, you'll be able to learn other languages easier. And because of the concepts you learn, because of the commonalities of the other languages, that's kind of the same thing, where, we're going to kind of learn about object-oriented programming and everything about what that means. And then because of that, you're going to be able to learn the same concepts apply to other object-oriented programming languages. And there's kind of analogies to it. Basically, it's kind of like making more understandable code. I'm just trying to explain it in kind of a way that makes sense, like where, like an object, like you can create a program that will kind of have like, like let's say you have a Toyota. It's a type of car that'll kind of belong to the car class, right? Where a Toyota is a type of car. And the way you understand what a Toyota is by understanding what a car is. Because a Toyota inherits all of the attributes of a car, because it's what a car is. But yeah, we're going to go through that, in a lot of ways. I think there's a question: how do the majority of users utilize Java? From your experience? Trying to figure out the meaning of that question. But in general, as far as like a user of Java, I mean, Java is one of the most like, like basically Java is like a very cross-platform language. So that's kind of another thing about it, is basically, you can have like a Mac, like a computer, like an Apple product. I don't have any Apple products, but you can have like an Apple product. You can have any kind of system, and Java will work on it. So Java is like very cross-platform, meaning that all cross-platform means is that any kind of system, any kind of computer, Java will work on it. So, just kind of reading through it. It is a general purpose programming language intended to let programmers write once, run everywhere, meaning that compiled Java code can run on all platforms that support Java without the need to recompile. Java applications are typically compiled to bytecode that can run on any virtual machines, JVMs, regardless of the underlying computer architecture. The syntax of Java is similar to C, C++, but has fewer low-level faculties than either of them. The runtime provides dynamic capabilities. Yeah, so just in general, as I've kind of mentioned, this notion of compilers is kind of a word we used, where, it's like we kind of like tried to write that pseudo program, like what I call pseudocode, which is basically like writing kind of what a program. It's kind of like, first, like, people write pseudocode, where it'll kind of like, it's kind of like you're writing out how you think the program will be, right? Where it's like that you're actually writing the code down, but not exactly. But we can't, like, if it's a compiler, it'll basically compile the entire code, right, at once, and then execute the program. Whereas other programming languages like Python, it uses an interpreter. So an interpreter basically just means that it's gonna execute each code line by line, but they do the same thing. They basically both accomplish running a program. So that's basically what the Hello World program is like. Is just to say, Hello World is kind of like the base case of a program, and that's what Java is as a program, as a programming language. Now we're gonna kind of learn this notion of comments. Now, I kind of think of them more as programming notes as comments, because comments, it's not like on the YouTube comments or anything like that. What a comment is, it's kind of in line with the word documentation. And what you want to do is you want to write well-documented code, so that code, basically, it's like you're not just trying to write code that's understandable to the user, the person that is receiving the result of the code. Like, if, let's say, you're a programmer, you're building someone a calculator program, right? And then they use it, and all they see is they're able to type in the numbers and then get the result. What you also want to do is, let's say you're working with other programmers. You don't want it to be a situation where they're just seeing all this code. The other program's like, okay, I'll help you work on this program, and then they, see your code, and then, nothing's really explained. So basically what you do is you make these kind of like notes that explain what each kind of line of code or block of code kind of does. Not each line of code, but every once in a while you want to kind of explain what you're doing, and there's a way to do that. Because you can't just type in like randomly, like, oh, this piece of code does this or that, because like what will happen? Will it run that accidentally? Will it create an error? So what you can do is you can write non-executable code called a comment, and I'll show you how to do that. And it's different for different programming languages, but let's get back to the coding. Let's make a comment. This program will say hello world. So what this basically means is, let's run it, right? And it'll do the same thing. As you can see, I think it's running it now. Where this line, you won't have to worry about this note here telling the programmer what it'll do, because it's going to see these two. It's going to see these two slashes. What this says to the Java compiler is, don't run this code, right? And let's say we're doing this, run this line of code. So basically, what the purpose of this is to kind of give the programmer a note, an idea of what you kind of want to do, what this kind of code means, so that when you hand your program off to another person, that they understand what you're doing. But let's say you have more to say. You don't want it to just be a line of code. Something you can do is you can write multi-line codes. And this is a great program. I don't know. So now you have a situation where it is a multi-lined code. So basically what you want to kind of do is, instead of // it's slash, some reason I'm blanking on what that's called. Is that is it a slash? I don't know, but that's what it is. You do a slash that thing, and then before each line you make sure you're including that, and then just put that thing and then slash. So that's the syntax for multi-line codes. for multi-line comments, and this is the syntax for a single comment. So that is the Hello World program. I think what we're going to get into next is variables. We're going to get into variables, if statements, data types, and we're going to apply that to make a calculator. So let's make a program. We're going to eventually turn this into a calculator, not quite yet, but we're going to turn it into a calculator. So let's get this downloaded. That's how you create a new program, new project. So when you go into source, it's going to have a main class set up. So what the main class basically is it'll actually look for this part, because this is like the starting point of the program. So this main class, that's what's called a main class, is like the part of the program that the compiler knows to start. So it's kind of like whatever you have. It's like whatever you have going on, this is where it's going to start. This is the main class. And we'll learn more about this. You'll kind of see this more as we go on. I think it'll just be better learning to just see it just in action rather than explained. But I think what it does actually already is it kind of, the Hello World program is kind of the universal way of knowing, of kind of like your first program in that programming language. So it kind of already says Hello World, right there. So for now, let's try to create a program. Let's try to create a calculator. So, as we have explained, a variable is pretty much like a storage of memory to store a piece of data. So, let's say I'm going to store a number. Int number equals 7. And then int number 2, or actually I'll make this number 1. Number 2, let's make that 13. So what has happened here? So basically int right here, that means integer. So we've created an integer, and we created an integer and we named it number 1 and set it to 7. That's what this does. Here we created an integer named number 2 and set it to 13. So now we're going to create a sum. And that's going to be equal to number 1, and it fills it in right there, plus number 2. And if we... And basically what this system.out.println is basically what it'll do is it'll like every time you see like the code, every time you saw like hello world in the console or hello world in the output, it basically will print the output. So when I say this sum, whoa. So if I have sum here, right? It'll actually, so here's what will happen. We've created an integer number 1 to equal 7. We've created an integer number 2 to equal 13, and I've created another integer that's going to equal whatever is in number 1 plus number 2. Now, what's in number 1? It's 7. What's in number 2? 13. Now, you probably know what 7 plus 13 is, right? It's 20. So if this program works, then sum should be 20. Let's see. Let's see if this Java program knows that 7 plus 13 is 20. Let's run it. And it'll just take a little while. Right there, see? So this is like the most basic version of a calculator. You know, let's kind of play around more. Int difference. And we're going to make that equal to number 1 minus number 2. And let's give some comments here. What did we do here? We created an integer named sum that adds number 1 and number 2. What we're saying here is we're creating an integer. Oh, whoops, I forgot to... See, that's actually what happens. If I were to just start talking, like let's say I actually do say, I just start talking and say created an integer. So here's the problem with that. It's saying red here because it's expecting it to be code. So if you don't give the proper like signals, right? You don't put the slash slash, or if it's a multi-line comment, the slash and star. That's what I just remembered it's called, a star slash star, and that followed by a star slash. Then it won't know that you're just trying to put in a note here. So you have to go back right here, and now it's grayed out because now you can write a note. So what did we do here? We're giving useful instructions to the other programmer. This is creating an integer named difference. That takes number 2 from number 1. The difference. So right after the sum, we're gonna see if we're gonna type in the difference. But let's add it up first. What is, so number 1 is 7, number 2 is 13. What's 13 minus 7? It's a negative number. It's negative 6. Let's see if it can handle that. it should say 20 and -6. So right there, 20 and -6. What else is there? There's multiplication, right? Oh, whoops. So we're gonna try to see about products. So we're gonna instead multiply number 1 times number 2. So what do? We created an integer named product that multiplies number 1 with number 2. So then it should do that. So what is 7 times 13? I don't know that in my head. What is it, 93? 7 times 13. Oh, is it 91 rather? Yep, it's 91. So it multiplies 7 and 13. Let's see other stuff. We'll see quotient. I just want to make sure I'm spelling this right, because I'm not really that good of a speller. Hold on. Yeah. Looks to be right. So we're gonna instead have number 1 dividing by number 2. So what do we do here? We created an integer named quotient that divides number 1 by number 2. And so it's literally going to say 7 divided by 3. 7 divided by 13. So I don't know what that is. That's 0.538. So let's display this. It says 0. It says 0. Why does it say 0? So something to understand about integers is basically an integer is kind of like the equivalent to a whole number. So an integer is going to be 1, 2, 3, 4, 5, 6, right? But what if you want like 3.14 or 4.5? And the reason why it said 0 is because it has to be a whole number. So because the actual answer, 7 divided by 13, is 0.538, it can't do it. So what we're going to do is we're actually going to try to change the, we're going to just kind of change the type here. And we're going to use doubles instead. So what's that going to do? What that's going to do, we'll see what it does. So what happens is now doubles makes it so that you can basically deal in decimals too. So the first thing, 7 plus 13, 20.0. 7 minus 13, negative 6.0. The difference, the product, num1 times num2, 91.0. And then we're able to get the actual answer. Instead of it saying 0, we'll get the quotient, which is number 1 divided by number 2. Being 0.538. So that's kind of a whole nother thing about data types. Is basically, I said that a variable is kind of like a piece of data stored in memory, and the question is like, how is that data stored? Is it a piece of text? Is it a number? Is it a true or false value? Something you can do is there's actually another. Let's actually just talk about a couple of them that you'll need to know. Called a string. Oh, it's actually a lowercase. That. No, it's not. Hold on. String Bob equals Bob. Yeah, it's uppercase. So if you have a string, basically a string, if you want to think about that, that's like a string of text, right? So then when it says Bob, it'll say Bob. Actually, that's a bad example because it says how about this? Bob's name. I'll change it to Bob's name because I wanted to say the same thing. So then it should say Bob. So let's wait till the program downloads. If you notice, it says Bob because now it's a string character. Now, this is another one. We're gonna call Bob's first initial. Oh, B. So what does that mean? What is a char? Basically, this stands for character, and a character is basically like a letter, or a piece of. It's basically like within a string, you basically have like an array of like letters, like B, O, B, right? So a character would just be the B or the O or the B. So let's just type that in here and see if it works. It should say B. And it does. Is there anything else? There's another one called Boolean. And we'll just say always false. And we'll set that to false. Actually, I think the convention is, I don't know. Then always false, just say false. So if you notice, something to explain here is a Boolean is a type of variable where the only value is true and false. So it's not displaying the string false. It actually knows that it's that kind of variable, and it knows that that Boolean is set to false. So this is kind of like another thing on data types. So now we're going to try to make a calculator where we're going to try to make a calculator that gives the user a choice of, it's going to give the user a choice of whether to add, subtract, multiply, or divide. So how we're going to do that is, I'm just going to, and these are called if statements. This is another big concept. I'm just reviewing where, I'm just making sure I get everything together. So in general, an if statement, let's kind of just give this a little space here, is if statements only deal in true and false. So how about we make, if we just say if how about we have like another one that says always true? Let's make another Boolean. Always true. Doesn't matter the question, it'll just always be true. So if always true equals true, dot print line always true is true. So what basically is here is if this condition, right? If whatever is in this is determined to be true or false, is determined to be true, then run this piece of code. So basically the computer can determine if that's true. So basically it'll look into always true, right? It'll look at the code and say, okay, always true is true. And is true equal to true? Yes. So then run this code. Now you're probably wondering about these two equals. So these two, think about these two equals as a question. So equals, if it was just one equals, that's called an assignment. So number 1 equaling 7, that's an assignment. Number 1 is then set equal to 7. But always true equals equals is kind of like saying always true, is that equal to true? And if that's true, then run this piece of code.
I didn't understand that.
Yeah, my phone's yelling at me. So think of when it's a double equal like that, it's a question. When it's a single equal, it's an assignment. So for this, and you want to end all the, lines of code with a semicolon. That shows the end of the statement. So let's see if this works. Let's just run the code. So it says right here, always true is true. Now, what if I make it false? Let's test if this works. So now, always true is true, right? So if I ask it if it's false, right, is always true false? The answer to that is no. So because this will be false, this code won't work. And if you notice, it doesn't work. It's not there. And something you can do is called an else statement. So an else statement is if, let's say this code, this condition is false. So this code will not run. So if that's true, then run this code. So it's kind of a good way to tell whether the if statement worked or not, because I'll just type it right now. System.o.print line we'll say not false. Is false. Always true is true. So because always true is true and it's not false, it's going to run this code instead. So if you notice, that's what it does. Always true is true. Now, what if I instead of using always true, I use always false? Well, always false is false. Let's just change it to false. Yeah. So always false is false. So this will be false. No, this will be true. Okay, I got confused, sorry. So, because always false is false, this statement will be true. Because false equals false. So, because false equals false, always false is false. Oh my god. Always false is false. Let's say I change that to true. Is always false true? So it runs this part of code instead of this part of the code. So if I explain that, is let's make another let's make it a char, and we'll call it op, and it won't be anything. Well, I'll just make it equal to a plus for now. If op equals plus how about we make another variable called answer, and we'll just set that to 0 for now. So when we set it to like anything, basically, it's called initializing it. So something you don't want is you don't want it to necessarily be a null value. So a null value is another word for null is nothing. So you don't want to set of any variable really to equal to nothing, because basically it'll create something called a null point exception. And what that means is it basically will say that, hey, this variable is not set to anything, you know, even though it's supposed to, so it freaks out. And it's called a null point exception. But that's another thing. We're just going to kind of set it to something and then, you know, see what happens. If the operation of choice is a plus, then answer should be number 1 plus number 2. Oh, and another thing is this is called an else if statement. This is another condition. So if op is equal to minus, then answer should be number 1 minus number 2. Let's make another else if statement. And if you notice, what it'll do is it'll actually fill it in for you and say like what it thinks you mean. It's kind of like when you type into Google, it'll kind of fill in the rest of the words for you, so it'll be able to, so you won't have to type the whole thing. That basically IntelliJ IDEA kind of does that for you too, and then it fills everything in right there. Let's say op equals a star, then that will be the signal to multiply them. Equals number 1 times number 2. And then let's say it's a you know, this is kind of like a signal for division, like that cross thing. Like if you were to type in, like in programming terms, if you were to say like, you know, 40 divided by 10, it's kind of like this is the equivalent of division. This is kind of like a division symbol. So else if the operation is slash, then answer will be number 1 divided by number 2. So we'll see what happens. Oh, I forgot to display the answer. That'd be an important part. System.out.println, because we're printing a line. Answer. It'll be the first line. Okay, so because, so let's see how this program works. So if op is plus, right, answer is going to be number 1 plus number 2. Op is plus, so that's what it did. So because of that, it made it to 20. So what if I change op to a minus? Then what it should do is, because it's a minus, it should subtract num2 from num1. Right? Let's try it. So again, 7 minus 13, that should be -6. It just did it. It just did it. Now let's change it to a star. So I said if it's a star, multiply them. We'll see it. Should be 91, I believe. 91. Right there. And if I change it to a slash, it should divide them. So then it's going to be 7 divided by 13, which is, some decimal point 538. So then you have kind of something that looks more like a calculator. Let's see if there's any comments. So I guess moving on. Explained how data types work. So I think the next step is we're gonna create a program, a calculator that's going to use something called the scanner variable. Now what the scanner variable is it's going to be the first time, it's kind of like a tool of Java, so that we're actually going to be able to, instead of basically just coding kind of the how the program works, it's going to basically make it so that the program's going to ask you, what is the first number? Then you're going to type it in. Then it's going to say, what do you want the operator to be? Then you would type it in, and then what is the second number? Do you want that to be? And then it's going to be able to type it in like an interactive program, instead of basically just displaying the result. So let's actually try that. call it scanner calc. I just gotta have my notes here. So, let's get the so basically, it's like to use like a tool like a scanner variable, we have to import it. So what it's actually, instead of a tool, it's really called a library, where it's basically like you're using some kind of like trick or something from Java to be able to use this scanner variable. So in order to use something, you have to actually borrow it. Util dot scanner. So it's grayed out because you haven't used it. I'm gonna make a scanner variable as simple as just to test it with the functionality. As simple as something that will just ask a question and then display the answer. We'll also make sure it's all typed right. Just hold on. System.in. Yeah, well, that was right. Okay. Say, what is your name? I'll actually put this up here. And it'll say, and then input will equal actually I'll make it input dot next line. And then once it does that, it'll print the name. Let's just see if that works. So, what is your name? My name is Ryan. Okay, so this works. Alright. So, what the scanner variable does is basically it allows user input to then influence how the program influence, but basically you'll be able to create a program to allow user input. So basically what happened here was it said, like, it just displays what is your name, and I forgot to kind of put a question mark, and then it asks you your name, and I typed in Ryan because that's my name, and then it prints out Ryan. So let's see that again. With a question mark this time. What is your name? What is your name? Ryan. Ryan. So we're gonna try to create a variable. We're gonna try to create a no, we're not trying to create a variable. We're gonna try to create a calculator that can use this functionality so that it can be more like a program where a user can use it. You know, where they're typing in kind of a number or something like that, you know, and they're able to kind of use it like it's an actual program. So let's just see. Actually, I think I'll have this, yeah, so actually I think, I'll actually leave this for the next, tutorial, probably tomorrow. Yeah, it's my getting a call. So yeah, so I'll actually leave this for the next, tutorial, but for now, what we've learned was kind of like, hopefully we reinforce the stuff we learned from the past to kind of make it so that we can implement that to real code that we can use.